Rene from LINBIT, going to be talking about some of the things they've been doing around CloudStack. So let's give Rene a welcome.
Thank you. Thank you. So yeah, as said, I'm Rene from LINBIT. I'm from Austria, and LINBIT is a company origin from Austria, Vienna. We have office also in US and some exclusive partner in Japan who is handling the contracts there, and the rest is shared between our US office and our Vienna office. We have basically 3 solutions right now as products. LINBIT SDS, which I will present you today, which is the thing you would use with CloudStack. And also LINBIT HA for high availability, and LINBIT DR for disaster recovery. LINBIT as a company started with DRBD, which is our basic technology. It's included in the Linux kernel since 2.643 Linux kernel. It is the block replication technology. It is open source. The currently shipped version with the kernel is still version 8, but we have already version 9, but is out of tree, and we are currently in the process of getting that merged in the tree back again. On top of that, we have also LINBIT Proxy, which is a commercial product, and then LINSTOR, which is a part of the SDS product. So LINBIT SDS, when it is a good fit, if you need persistent volumes for Kubernetes or any Docker container stuff, virtualization, like all platforms, CloudStack of course, OpenNebula, OpenStack, we have connectors or plugins for that, Proxmox. For database backing, storage backing, and also analytic processes if you need high read loadouts. Why is it fast? So the block replication is in the Linux kernel, not much context switches, it's very light on CPU and memory. Usually you can have it as a hyperconverged setup, and also there's a diskless mode, so reads and writes are over the network then. And if it's hyperconverged, you have the reads from the local disk, and the writes spread out to whatever you defined as how many replicas you want from your storage. And the thing about LINBIT SDS is we reuse all the bits and blocks from the Linux environment. So we use LVM or ZF, I don't know how it's pronounced, usually as CFS or ZFS. You can have looks in the mix, video for deduplication in the LVM context, and caching net, but I will get to that later. Yeah, what is it doing? You can have thousands of nodes, basically. I mean, not for the storage itself. DRBD is limited to 32 nodes. But usually you just want to have replicas for 2 or 3, maximum 3 nodes, because otherwise you just have storage wasted. Network, you can switch or have the separate networks between the data path and the communication path between LINSTOR. As a data replication, you can have synchronous mode and asynchronous mode with the pro and contra. You have consistency groups, which is not that much used in CloudStack use case, because usually you just will have one volume per disk for CloudStack. And yeah, you also have backup solutions in LINSTOR or LINBIT SDS, so you can put volumes on S3 or another LINSTOR cluster. So, as I said before, this is the Linux storage gems which we reuse basically. So you have LVM or ZFS in the mix, depending if you're using Ubuntu as your base operation system or Red Hat or CentOS. You can have in the mix software aid from Linux or NVMe over Fabrics, and caching if you need any of that, like Bcache or VMcache. So this is what LINSTOR does. LINSTOR is the software which combines all those things. It's also written in Java like CloudStack. And the goals for this is to build all the building blocks and keep them together and provide that for our consumers like Kubernetes or CloudStack OpenNebula. As I said, it's building on the Linux storage components, it's multi-tenants possible, and we use LVM or LVM Thin and ZFS for the volume management below. And you can have different deployment architectures depending on properties, which I will also get later. So for example, how this would look like in a hyperconverged setup. So you would have, this is your LINSTOR cluster, we have 6 nodes. And you have here, for example, 2 virtual machines running. This is the storage of the virtual machines, the storage devices themselves or the storage pool below them. And now you want to migrate basically this Docker virtual machine to this node. And in CloudStack you would just migrate this virtual machine. What happens then in LINSTOR is you would get from the plugin, it would move, not yet, or it can, but it must not move the virtual machine there. I mean, this is done from the hypervisor, of course. And then LINSTOR will still run there, not LINSTOR, but the virtual machine will run there. And in the background, it will run on the diskless mode from DRPD. So it will does the reads and writes from the data over the network. And there are certain settings you can have, like, okay, if this virtual machine runs longer than an hour on this other hypervisor, I wanted to get local storage. And so after 1 hour, you will get then the local storage there. And then there's another setting. You can say, okay, if this virtual machine stays there for a day, then I probably want it to be there. And then it will remove the additional replica from this other storage node, because you don't need it or don't want it.
I have a
Yeah.
question about if you go back to the
Yeah.
slides,
Yeah.
where the VM migrated from the upper hypervisor to that second
Yeah.
one, but the volume was also on the other hypervisor, so you could
Yeah.
also have chosen to migrate it to the different hypervisor where the storage would still be local.
Sure, yeah.
Is that something an admin needs to figure out, to say, hey, okay, what would be the other copy and move the VM, or can you say when moving the VM, move it to the other hypervisor where the storage is also present? Because this could be a potential performance killer when somebody migrates a VM without this knowledge, and so you suddenly go from local storage to network.
This is from the automatic way, but I think usually the connector, the plugin will, no, it will not. You're right, you would need to know where the storage is. If you want to move that, you can check that. I don't think you can see it in CloudStack itself, because it's transparent for it. But you can see it with the LINSTOR tools where the local volumes are, and which are, I mean, if they are not diskless there, they will be created there diskless for you. So you could, if you know in beforehand, okay, I wanted that there is no no performance lag, then you would probably choose a node where it's already have local storage.
So the storage transactions are asynchronous, favoring the local storage?
No, not for read.
Just for read.
For read. I mean,
Okay, so
you can run asynchronous mode. Then
But it's risky.
yeah, because it could lose some data in between then.
Okay, so even if you are gonna use local storage, you're still kind of, I mean, yeah, it's better than not, but you're still limited by the network aspect. Okay.
So now about LINSTOR, which is the basic part of LINBIT SDS, is it's a bit the same concept like CloudStack. So you have a controller, which would be the CloudStack management server, and then you have the LINSTOR satellite, which would be the CloudStack agent. And you should only have one LINSTOR controller running at one time. So if you have, you can run that in an HA setup, but there should be only one LINSTOR controller active at one time. And the LINSTOR controller talks to the satellites. So no satellite will create a connection with the controller. It's all started from the controller itself. And the controller you can control over a REST API or with a CLI, a command line program, or over we have some API libraries for Golang, Python, Java, and or just use plain curl calls with the REST API. And LINSTOR has objects, so like it has nodes, which are the like we've seen before. This would be LINSTOR node, LINSTOR node, LINSTOR node, and a resource is basically your volume for virtual machines. It can have more than one volume, but I think you will never see that in a CloudStack setup that a LINSTOR resource would have more than one volume, because this is more seen as a consistency group and is usually only used for databases where you have, for example, Oracle DB, and you need to have the log data at the same point or the same data like the real data. So they have to be in sync. Then you have snapshots, objects, which of course store the snapshots you do with LINSTOR. And storage pool would be your mapping to the LVM group, volume group, or the C pool. They can be shared in more complex setups, but usually you don't see them. And resource groups is then the mapping which you'd use as a primary storage in CloudStack. And resource groups are the place you can share settings and properties over a larger group of resources. And there's properties, it's here in the same list as objects, but basically every of these objects has properties below them. So you can set them. It's like the key value store you have in CloudStack, the global one, but here you have it per object. Yeah, and the LINSTOR storage layer can be constructed in a layer view, you can say. So you will always have at least the bottom layer, which is an LVM volume or a ZFS volume, and on top of that you can have looks or caches in between, and in the most setup, or in most setups, you will have on top DRBD for the data replication. But you can also create the resource in LINSTOR just having a LVM volume if you need it for something. And below that, or under your C pool, you can have a software RAID, which makes for ZFS no sense because you already get that from a C RAID, or VDO in combination with LVM for deduplication. And yeah, you can have rules on how data is placed in your cluster. Like you can give nodes the rack number, for example, and the room number, and a site. And then depending on the values, like it's like a key value store, you can either have them rules say, okay, I want a resource on racks with the number 1, and you can also say I want the resource distributed exactly not only on the rack 1, so to distribute your failure points. So if you have one rack room which goes on fire and it's broken, you want to have at least replicas in your other side or other room, and you can express this with these property values and rules in the resource group with the placement. Yeah, you can also have define different network interfaces for a storage pool or a node. So here comes again, like I want all the DRBD traffic data on a specific NIC and all the LINSTOR data, so the control plane on another NIC. So if you have really like saturated your DPD network, it could happen that then LINSTOR can't communicate with each other because it is so overwhelmed by the DRBD replication data that you get problems there. And so one way would be to have a second network interface card and have just the DRBD data over that NIC. And yeah, DRBD has RDMA support also, and you can also configure that, of course. So the recent things that got into LINSTOR was volume, snapshot, and snapshot delta shipment. So you can now, as I said before, do snapshots in LINSTOR and ship them to S3 backups like MinIO servers or ABS S3, and also have them between LINSTOR clusters, so you can ship a whole snapshot there and then incremental ones, so you don't have to copy the data all the time, the full data. Then we introduced support for Kubernetes custom resource definitions. I think CRD is the shortcut, which lifts the need for Kubernetes setup. You needed an extra etcd container running to store, or it was easier with the ECD than having a SQL database running with Kubernetes in that setup. And now you can directly use the Kubernetes custom resource definitions. We have support now for ABS EBS volumes, so you can use that if you have a cluster running in an ABS environment. And yeah, current roadmap is that we improve our handling on disk failures. It works, but we just need to improve the story a bit so we get better log output on which disk failed on which node, and maybe get also some kind of alerting there. And yeah, also currently in the works is a LINSTOR database conversation tool. LINSTOR currently supports etcd, then an embedded H2 Java database, and all kind of SQL databases like Postgres, MySQL, and also the CRD stuff. And we want to get rid of the etcd database, but for that we have to provide a way to convert etcd database into the CRD stuff or into MySQL. And that's what's currently in the work. So yeah, this is our current connectors. I already mentioned them. So we have Kubernetes and Novat. These are all run by the CSI driver. Then we have a Cinder driver already since 2019 for OpenStack, an Open Nebula storage driver, Proxmox, XCP-ng. This driver is not developed by ourselves. It's from our partners Vates, which are running the XCP-ng, and the Apache CloudStack driver, which I wrote, and I will highlight the stuff it cans in a later slide. Then there is also the distinctions. We have LINBIT SDS for Kubernetes, or we have a Purea store, which is the open source variant, and the LINBIT SDS, which is our commercial variant, which is based then on Red Hat UBI based container images, and the other one is then on Debian. And you see the differences here also listed. But it's in the end it's the same source. It's just that the one has more support and has the official container images from Red Hat. Yeah, then here again, translation metrics for what would be a resource group in one of these connectors. And as I said, in CloudStack, the resource group would map to a primary storage, and the resource volume would be just the volume in the CloudStack environment. Yeah, the CloudStack driver is in upstream since 4.16. It has support currently only for KVM hypervisors. It is a primary storage driver. It supports volume snapshots, and you can also live migrate virtual machines in there. Since 4.18, I added support for IOPS quality of service settings. I also fixed a bug in CloudStack with that. And yeah, upcoming, which might already work, I just had not enough time yet to really confirm it, is that maybe out of the box it already works, that you can run the LINSTOR with XCP-ng with this, I think it's called XOSTOR, is the driver which is written by Vates, and I guess it should already work, but I didn't have the time to confirm it really. But this will be next thing, that we make it working in that environment. So, yeah. And that was also a bit too fast. Thank you, yeah, and I'm open for questions. Yes?
Yeah, on the naming of the product, you mentioned LINBIT SDS, and you also mentioned LINSTOR, and I'm confused what the storage product is.
The product for customers is LINBIT SDS, and LINSTOR is one part of it, basically. So if you're talking about LINBIT SDS, it would be a combination of LINSTOR, which is the main part, DRBD, which does the storage replication, and yeah, that's basically the two main products combined, and then the overall product name is LINBIT SDS.
And you mentioned shipping snapshot deltas between clusters. Are these in kind of a LINBIT format, or are they in, say, ZFS format, or?
Yes, they're in the native format. So we use ZFS send and receive in the backend, or LVM. For LVM, we had to write a small tool which is called fin send and receive, which does basically the same what ZFS would do. And yeah, and that all of this is open source. Just if I didn't mention that, so you can download it and build it on your own.
So Piraeus data store is basically just the open source bits from LINBIT plus DRBD.
Yeah, but for the Kubernetes environment.
This is strictly for
Yeah, it's strictly for Kubernetes, or for that. I'm not the expert in Kubernetes, as a colleague for me, so.
Regarding XCP-ng, what's the difference using the CloudStack plugin to perform actions instead of using the preset up and doing this XAPI all the actions?
Basically the hypervisor. So from my knowledge is that the KVM has a different API or a driver between XCP-ng and KVM. And for KVM, I have written also parts in the CloudStack agent, because I need to know when a host wants to access a volume or not, to get this diskless dynamic stuff working. And from what I saw right now is that in XCP-ng this infrastructure is a bit different, and I think it uses directly the API from XCP-ng for that. And that's also why my hopes is that it will just work. I just had no time to really set up and cluster with that. And maybe someone can give me some insight from you today in the pub later on how to get it running.
We just tried the preset up from CloudStack perspective, and this works because it's just a storage repository.
Okay, yeah, I mean,
primary storage.
Yeah.
Sorry to interrupt. In KVM, when you have a block storage system integrated with like a KVM orchestration or CloudStack, you get a separate volume in the storage system with short-term disk, right? The typical way you use Zen server XCP-ng is you give it a large one, and then it does its LDN thing or whatever it does on top. LDN, and then to use it in this way, you don't need an integration. And as you said, you create one storage resource in that server, and then CloudStack just works. Back in kind of CloudStack context, back in the storage file integration, they had this with Zen server. They had this concept of having a separate storage resource that all disk for each virtual disk, even in Zen server. So an integration of block storage solution with CloudStack and Zen server would also have that. It would have separate room for each virtual disk.
Okay.
Instead of having a large one.
So you will end up in just thousands of storage repositories in this way. Okay, get it.
And what that gives you is storage management features on the bottom there in the storage solution instead of using the consumption.
Any other questions, Rene? Thank you.